Hi everybody, welcome back. Today we're going to finish off the application questions for 1.1, the question 3 and 4. So in question number 3, this is the first time we've come across an arithmetic sequence that has a variable in it. It's done the exact same way. However, this time we're going to have a variable in our difference, right, as you can see. So when we subtracted a binomial like this, x plus 8 or 3x plus 6, which they tell us is arithmetic, so we know it's going up by the same amount. And you can clearly see if you take a look, if I took 3x from the second and subtracted x, I would get 2x. And if I took 6 and subtract 8, I would get negative 2. Do the same thing from the third and second term. I take 5x, I subtract 3x, I get 2x. Take 4, subtract 6, I get negative 2. So from this information, we can see that the difference d is equal to 2x minus 2. The first term, t1 is equal to, again it's the first term, x plus 8. Next, we know we have n. If you read the question says we have n is equal to 12, because right here it says find the 12th term. So we're looking for the 12th term. So this is t to the n, or we can put in t to the 12th, because that's what we're looking for. So t to the 12th is equal to question mark. Or what I like to do is I like to put it as t to the n, just so we're a little less confused maybe. I go up, I grab my formula, remember the same formula we've been using all along. There we go. And we plug it in. So once I plug it in, then I usually change it. It's just a habit for me. I'll take this and I'll put in now, okay, I'm looking for 12, so I'll put 12 here. First term we know is x plus 8, so I'll take that. I'll replace t1 with x plus 8. N we know is 12. I'll replace that with 12. And our common difference is 2x plus 2. So I'm definitely going to put a bracket around that. There's two terms in it for sure, just so we're not confused. Then I'm going to rewrite, and I'll collect any like terms. I can't collect the x plus 8 yet, can't add them, but I can take the 12, subtract 1 to make that 11 now. And remember, the 11 is going to be multiplied by the 2x and the minus 2. That's why it's in brackets, the distributive property. Very important that we don't forget that. So now I'm going to take the 11, multiply it by 2x, and I'm going to end up with 22x. Then I'll take the 11 and multiply by the negative 2 and end up with negative 22. And it's at this point now where I can collect my like terms. I have my variable x, and I have my constants. So the x plus 22x is going to give us 23x. And the 8 minus the 22, maybe I'll just write it out. 23x minus 14. 8 subtract 22. And there is my 12th term. My 12th term is going to be 23x minus 14. And that's it. It's finished. There's nothing else we can do with it. If we knew what x was, then we could substitute it in to get a value, but we don't know. If we had another pattern with x, then maybe we could set up a system of equations or something to the effect. But at this point now, that's it. It's finished. There's nothing else we can do with that. So the 12th term will be equal to 23x minus 14. All right. And our last example from 1.1 is a plumber charges $50 for making a house call. In addition to that, he or she charges $30 per hour or any portion of an hour. So basically means if the plumber's there for 45 minutes, they're still going to be paid $30 an hour. It usually rounds up from experience. So it says generate the possible charges excluding parts for the first hour. So what I like to do is I like to create a table of values. It's completely up to yourself. So I'll do a quick table of values. I'm going to do the table of values horizontal, just how my page looks. So I'll go 6 by 3. You'll see why in a minute. So first column, I'll call this is the term in the sequence. So first term, second term, third term, fourth term, fifth term. That'll give me enough there. So the first thing here, this is the term in the sequence, and then this is the number of hours worked. So put the number of hours worked there. And so you'll notice that coincides with the term. They're the same. And then the cost will be our next one. So the cost is going to be, and that's in $. Units. Now, after 1 hour, if it's cost $50 for just showing up, $50 plus $30 per hour, that's going to be 80, and then it's going to increase by 30 each time. So there's my value. So I'm literally just getting that from the information from the problem, because it said there's $50 for making a house call. So that's 0 hours. Just showing up is $50, and then $30 per hour. These are questions that you may recall from grade 10 and even grade 9 as well. So generate possible charges excluding parts for this. So excluding parts means so if they show up to fix your plumbing, this is not including any new piping that needs to be put in, any new faucets, any of the connections, anything like that. So this is just the labor. We call this labor, as you guys do recall, or could recall. Sorry. So now we're going to sketch a graph for the sequence. So what I'd like to do here to sketch this graph is I will use a program for this, and I will put the plots on there. So just bear with me for a minute. So you'll notice your screen has changed here. What I've done is I've used a program called Desmos, and it's just a nice graphing program. So I've labeled all my points for my graph, as you see here. So 1 and 80, 2 and 110, 3 and 140, 4 and 175, and 200. So I'll click back to my Desmos, which is a free online program. I'll show you how to use it. It's fantastic. So I've plotted all the points there, and you'll notice that to answer the question, it says sketch a graph of the sequence, discuss the relationship between the arithmetic sequences and linears used in this example. So I have the hours on the bottom, 1, 2, 3, 4, 5. I have the cost on the vertical axis, the y-axis, 50, 100, 150, and 200. And you'll notice that there's a line that goes right through that. And I know what the equation is, so I'm just going to put it in. And you'll see that it clearly is, when I graph this line, it's going to go right through it. So it's going to be y equals, now we know we're going up by 30, so that's where the 30x comes in. You'll notice the line is down. And remember, the initial cost was $50 just to show up. And then once I hit the 58, the line goes right through. So it is indeed, the relationship is the same. So in an arithmetic sequence and a linear function, the relationship is, I won't say the same, we'll say equivalent, is maybe be a better word. So I'm going to take a picture of that graph using a program that we have, and I'll put that in your problems there, in your answer key. So just bear with me. This is a neat little program, so I just take a little clip of this, and I go like that, and there we are. So I'll cut that. I'll bring that over to your graph. Of course, it's going to be huge, but then I'll just make it smaller, so it fits on your page really nice there. Text. So, graph. So to answer the question, it says discuss the relationship between, and the relationship is the same or equivalent, we can say. You can clearly see as we do that now. So the difference, let's just take it here. So that the common difference, that D, we'll just show D. You guys know the common difference is D. So D is equal to the slope for an arithmetic sequence. Because remember, we put the equation in y equals mx plus b, and I put the y equals 30. And the first point, the initial point, t1, has a relationship there. It's not 50. We always have to go back one, but we'll talk about that. But the relationship, so the slope is equal to the common difference. So after those videos, I know there's a little bit. That's usually what happens when we start a new section. It takes us a little bit to get through. I hope you enjoyed the videos. This is a new approach that I want to look at. I heard of another teacher doing something similar, and I said I think that'd be great. So I'm trying the videos. Any feedback would be great. I appreciate you taking the opportunity to go through the videos. The homework there is provided. It's from our textbook, Pre-Calculus 11, which I've already handed out to you. It's on page 16, and it's numbers 1 through 11, 14, and 16. I hope you're enjoying the videos. Like I said, some feedback would be great, and I look forward to the next section, 1.2. Thanks, guys.